Hello, good day once again. So this lesson is basically trying to show an example on what we studied so far on Thevenin's theorem. So this is a typical question here, and I want to really go straight forward on how we can find the current that will pass through this 10 ohm resistor, specifically only this 10 ohm resistor. We don't want to go through any other sources. We want the current that will pass through this 10 ohm resistor. Okay, so the current that passes through this 10 ohm resistor, from the theorem, we understand that there are two things you are supposed to take note: finding the Thevenin's voltage and finding the Thevenin's resistance. The two of them, when you're able to find it, then the current that will pass through the particular resistor becomes the VTH plus RTH plus divided by R2 plus the actual resistor in which you want to find the current. So now, what we do here is that to find the VTH, so finding VTH. So if you want to find the VTH, the first step says that you have to open circuit that particular. So let's say the 10 ohms is here. You have to open circuit that particular resistor source. And let's name our terminal. Now, after naming our terminal, what do is that we have to introduce the Thevenin's voltage, which is VTH. So I introduce it within this direction. Okay. Now, after introducing the Thevenin voltage, we can solve for the Thevenin voltage now by applying the Kirchhoff's voltage loops. Now, what do we do here? You realize that because this place is open circuited, I'm using the same diagram to draw it. I should have drawn a free diagram, but because of the board. So, because this place is short circuited, the current that is produced from this voltage will pass through this same place. And let's say that current is I1. So the current that will come through wouldn't pass through here. All the current will now pass through this same line because here is short circuit. It's open circuited, and it means it has infinite resistance. The same way, the current that is produced by the 6 volt will also pass through here. They'll get here at this junction, they'll all pass through here again. So the current through here, let's say it's I2. Because this open circuit will resist all the current from passing through it. So now, since we have this, we can now apply our KVL. That is our Kirchhoff voltage loop. Now, how do you do it? I will take this first loop in this direction, anti-clockwise. So now, when I take it down to C, B, G, F, and back to C. Now, when I take this first loop, what happens? This is the only voltage source in this first loop. So the VTH, I took it in this direction. So I'm going to this direction. I meet a resistor, so which is equal to 15 times the current that is passing through I1. I go back and I meet another resistor, but the current that is passing through is opposite. So it becomes minus 8 I2. Okay, and let's take this as equation 1. Now let me come to this side. So because here is positive and current will flow in this direction, it's flowing in this direction, I want to take it clockwise direction, my loop. So for taking my loop clockwise, I have A, I have B, I have G, I have H, and I come back to A. So when I do this, what happens is that I find only one voltage, so 4 volts is equal to the same current passes through the 15, the same current will pass through the 5. That's I1. So I have 5 plus 15 I1. And here I can determine the I1. So the I1 will simply become 4 on 20 ampere, which is 1 on 5 ampere. Now, I can't do this loop because the positive terminal is also here. I want to take an anti-clockwise direction. So I come DC, FED. That's my loop. So upon taking this loop, I have my 6 volts. That is my EMF. There's a potential difference here, which is 12 plus 8, because the same current passes through it. So 12 plus 8 and I2. So what do I get here? I can find my I2. My I2 simply becomes 6 on 20. 6 on 20 ampere, which is simple 3 on 10 ampere. Okay, so now I want to find the voltage at last. So how do I calculate for the voltage? So therefore, the VTH will now be equal to 15 I1. So the I1 calculated was 1 on 5 minus the 8 I2, which was calculated as 3 on 10. So when you do this calculation, this goes here, so the VTH finally becomes 3 minus 24 on 10. And when you do this, you get 3 on 5 volt. So now, this calculation or this circuit will provide 3 on 5 Thevenin voltage. Now, after getting this, what do? We have to now come to calculate the Thevenin resistance. How do you go about it? Now, with the Thevenin resistance, it's also very simple. Let me use this same diagram to draw the Thevenin resistance. So the resistance says that, or the rule for the resistance says that when we place the Thevenin voltage or the resistor in which we are finding the current, we should introduce the Thevenin resistance over there. So now we've introduced it. Now, after introducing it, we have to short circuit all sources. That is especially the voltage sources. So now we have one voltage here. We short circuit that voltage source. We have another voltage here. We have to short circuit that voltage source. Now, when we short circuit these voltage sources, what do we have? We have 4 resistors left. So the Thevenin resistance here is simplifying the effective resistance of the resistors left. So now, to find the effective resistance, you realize that 5 ohms and 15 ohms, because there is a junction here, different current to pass through, so they are parallel to each other. Because we experience same voltage, they are parallel to each other. Now, if they are parallel to each other, then 5 is parallel to each other. So 5 is parallel to the 15. So the effective resistance over there is simple 1 on 5 plus, that is the effective resistance, let's say it's R1. So therefore that R1 will become 1 over R1, which will give 1 on 5 plus 1 on 15. So now this R1 will simply be equal to 5 times 15 divided by 5 plus 15. Okay. Now 8 ohm resistance and the 12 ohm resistor, they are also in parallel. So if they are also in parallel, 12 is also in parallel with the 8. Let's find the effective resistance as R2. So the effective resistance now becomes 1 over R2, which is equal to 1 on 12 plus 1 on 8. So the R2 now becomes 12 times 8 divided by 12 plus 8. So now, when you do this, you get the effective resistance for R1 and R2. Now, what happens is that the R1 now to the RTH, now to the R2. So if you want to find the effective resistance here, you realize that they will now be in series. So the effective resistance for the R1 we found, the R2 we found will now be in series. So that will, the RTH will simply be equal to R1 plus what? R2. That's the effective resistance of the two effective resistance we've already found. So therefore the RTH is simple 5 times 15 over 5 plus 15 plus 12 times 8 divided by 12 plus 8. And when you do this, we are getting 171 on 20 ohms. Now, if you have this, then to find the current through the 10 ohm resistor now becomes very simple. So the current through the 10 ohm resistor, okay, so we had the RTH as 171 over 20 ohms, and the VTH, we had it as 3 on 5 volts. So therefore, we want to find the current through the 10 ohm resistor. So now, we draw our circuit. So the VTH RTH. We introduce our 10 ohm resistor. So the current that passes through, let's call that current I. So now, if that current is now I, then the I is simply equal to VTH all over the RTH plus the resistor. Because we are in series, the same current will pass through. Okay. If this is so, then I is therefore equal to VTH, which is 3 on 5 divided by 171 on 20 plus 10 ohms. Now when you do this calculation, this is why we get it 0.032 ampere. And this 0.032 ampere, that is the current that passes through the 10 ohm resistor in this electric circuit diagram. And this brings us to the end of today's lesson on examples of Thevenin theorem. I'd like you to go get a lot of examples to solve. If you find any example and you're having a difficulty, you can send the question to the email you see under the video. The email you see under the video, you can send the question to that and it will be addressed for you very much. When you send the question through that email, you address the question and we will give you the solution to the question. Thank you very much, and I'll see you next time for Norton's theorem. Bye.